about mutually exclusive events, okay? So thinking about the deck of cards again, we want to find the probability of drawing a queen or a jack. And we've actually already done problems like this. I asked you problems, what's the probability that we roll a 5 or a 6 on a die? And you knew that there was two numbers that were on a die that were either 5 or 6 out of the 6 total. And you didn't have to worry about any overlapping because you can't roll a 5 and a 6 at the same time. Well, the same thing here with a queen or a jack. There are no queens that are also jacks, and there are no jacks that are also queens. And so the probability of picking a queen or a jack is just going to be the probability of, let's count up the number of queens. There are 4 queens in the deck. There are also 4 jacks in the deck, and there are still 52 cards. So I'm just adding up all the queens and jacks. So I have 8 chances of getting a card that I'd be happy with out of the 52 cards. And again, we can divide by 2. That gives us 4 over 26. We could divide by 2 again. That gives us 2 over 13. So the probability would be 2 over 13. We could also write that as a decimal. So that would be 0.154 or 15.4%. So all of these would be valid answers. If they specifically ask for a proportion or a percent, then make sure you're giving that. If they ask for a fraction, make sure you're giving that. Okay, so mutually exclusive events are events that have no outcomes in common. And so that means that the intersection of A and B is 0. And so the formula still holds true. What I did here was I found the probability of a queen plus the probability of a jack, and then I subtracted the probability that it was a queen and a jack at the same time. But it just turned out that the probability of getting a queen and a jack at the same time, picking out one card, is 0. And so I just had to add the two probabilities together. 4 over 52 plus another 4 over 52 is 8 over 52, which is 4 over 26, which is 2 over 13. So, mutually exclusive events. There are no clubs that are also hearts. There are no hearts that are also spades. So we want to know what's the probability of picking a club, a heart, or a spade. Okay? Well, the probability of picking a club, a heart, or a spade is going to be the probability of picking a club plus the probability of picking a heart plus the probability of picking a spade. And if you just want to always subtract out where they're in common, that's fine. We could still write that in the formula, minus the probability that it's a club and a heart and a spade. But I don't know any cards in the deck, a standard deck of 52 cards, I don't know any cards in the deck that are both a club, heart, and a spade at the same time. And so this is 0. And so it's really just 13 out of 52 plus another 13 out of 52 plus another 13 out of 52, which is 39 out of 52. We just add the numerators, which is 3/4 of the deck, or 0.75, or 75%. Really, the only cards that would not give me a desirable outcome here is a diamond. So those are mutually exclusive events. So now let's put this all together, okay? According to a California Department of Motor Vehicles report, there were 214,811 DUI arrests in the state of California in 2008. Of those arrested, 172,220 were male. 92,936 were between the ages of 21 and 30, and 74,317 were males between the ages of 21 and 30. So what's the probability that a random person arrested for DUI in California in 2008 was male or 21 to 30 years old? Okay, so we want to find the probability that someone was male or between 21 and 30. All right, so that's going to be the probability that someone's male plus the probability that they're between 21 and 30 minus the probability that they were both male and between 21 and 30. Okay? So I'm going to finish this down here, sorry. So the probability that they're male is 172,220 plus, that's just the number that were male, plus the number of people that were between 21 and 30, that's 92,936, minus the 74,317 that are both male and between 21 and 30. And I'm going to divide that by the total. Okay. So the total is 214,811. Okay. So, and don't be afraid to use your calculator to do these things. I'm surely doing that on my own right now. So the numerator comes out to 190,839. The denominator is still 214,811. So if I take that previous answer, the numerator divided by 214,811, I get 0.888 or 88.8%. And if you want to reduce that fraction, you can. So it's an 88.8% chance that the person was male or 21 to 30 years old, which is less than 100%. So that means I'm feeling good about this answer. If I just added up the total number of males and the people who were between 21 and 30, I would get a number that's over the 214,000. And so that wouldn't make sense. So now, what's the probability that a random person arrested for DUI in California was not male nor 21 to 30 years old? So we're looking for not male and not 21 to 30. Okay? Well, we just found out if they were male or 21 to 30, we just found out the probability. So now we're just trying to figure out if it's not either of those, that means it's female and outside the range of 21 to 30. Okay? So that would just be the rest of the percent that's left here. So we're using the complement to do this problem. We could figure it out in other ways, but I think the easiest way to do this is to say that the number of people that are not, so if we're looking for the probability that we're not male and not 21 to 30, that's the same thing as finding 1, which is the probability 100%, minus the probability that they were male or 21 to 30. So we can just subtract from 1 our previous answer, and that will give us the solution here. So this gives us 0.112, which is 11.2%. I hope that made sense.